Thanks everybody for joining the webinar today. We're going to be talking about SaaS applications and how a distributed SQL database can help with certain areas of performance for your applications. So first of all, let me say good morning, good afternoon, or good evening, whichever one applies. My name is Karen Hutton, and I'm Director of Demand Generation here at PingCap, and I'll be your MC for the event. If you have any questions during the presentation, put them in the chat, and we will address as many as we can at the end of the session. And if we can't get to them all, we'll reply by email to you. They will be, what you type in will be recorded and we can follow up. But first, let's get us all on the same page by making a brief introduction about the topic. And fundamentally, what we've seen is that SaaS companies continue to experience rapid growth as buying habits shift from analog in-person interactions to fully digital transactions. And we've seen this increase, meaning that the demand impacts all facets of a SaaS business, but none more so than its data. And so in today's webinar, Liquan Pei, our technical evangelist at PingCap, he's going to explore the challenges of scaling your modern SaaS applications and how they can be solved with a distributed SQL database, which we see as a practical solution for your extreme application scalability, reliability, and versatility. So about Liquan, before PingCap, he was the tech lead of the ad stream processing system at Pinterest, and he worked at Confluent before that, focusing on Kafka Connect. Can we go to the next slide? I think that's where we have kind of the summary about Liquan and his email. And he is also an open source contributor to Apache Kafka, Apache Spark, and a frequent conference speaker. So again, drop your questions directly in the chat as we go, and then we'll be sure to answer as many as we can after the end of his presentation, which should take about 20-25 minutes. And with that, it's all yours, Liquan.
Yeah, thank you, Karen, for the introduction. Yeah, let's get started. So let's start with this. Okay, so I believe everyone has used either Excel or spreadsheet in Google Spreadsheet. So I view SaaS as kind of like an advanced version of spreadsheet or Google Spreadsheet or Excel, with kind of like focusing on different verticals. I think the first SaaS probably people will recall is Salesforce. It's a customer relationship management software. But in the essence, really a database or really spreadsheet for you to manage your customer information and record the interaction between your sales rep and the customers. Yeah, there are many, many more of the solutions. And today I will use Airtable as an example here. If you think about Airtable is an enhanced version of Excel or spreadsheet. It's really like provided as a service for you to do, right? It's a SaaS service. You can sign up, and then you can also, like, your organization can use it. And beyond like a spreadsheet, Airtable also offer other capabilities, like integrating other data sources like Salesforce, HubSpot, or your own data sources. And then it also allow you to build kind of like internal applications, use that data, different views, different kind of like workflows. If you look at Airtable, Airtable can be used as a project management tool, a CRM, and also a financial planning tool. So, and there are many, many verticals has more specialized software. And you can all categorize those softwares as a data-intensive SaaS. meaning that spreadsheet-like things or more enhanced version of spreadsheet focusing on vertical use cases. And actually, data-intensive SaaS is everywhere. It can be in the form of low-code or no-code, like Airtable, what I just mentioned. It can also be focusing more on the vertical side. There are many CRMs, there are many customer success platforms like Catalyst, like Salesforce. And there are many data aggregators as well in fintech. There are many know your customers or know your business softwares. They actually gather data from the from the internet and then provide it to the users to understand a certain person, for example, alloy or persona. So it's actually everywhere. You can imagine a lot of them. So let's take a look at, for this category of SaaS with a spreadsheet like, which are data intensive, what are the functional and kind of non-functional requirements? Think about spreadsheet, right? There are a couple of functionalities. I think the first functionality is actually collaboration. So this software allows many people to edit and contribute the same content. And then the second kind of most important functionality is really produce or integrate of your mission critical data in your organization. For example, Salesforce, if you use Airtable, many people want to integrate with Salesforce or Jira or Zendesk. And that allows you to create a view across data sources to provide generate insights. And then from the view perspective, we want multiple views, right? You can use Kanban view to understand the progress of projects, and then grid view to understand kind of like different visualizations or different kind of trends from your data. And majority of the time, imagine a user of Salesforce. You want to create a view to understand the performance of your sales reps. Then you issue kind of like ad-hoc queries to the system on kind of like arbitrary fields. For example, you want to order the performance either by regions or by kind of start date or different kind of like dimensions. And over time, your data is not kind of static, it frequently changes over time. So meaning that the data model of the application will change over time. And basically those are the requirements for those data intensive SaaS. And because nowadays, these applications are often offered as a service. And then there are also the non-functional requirements for those applications. For example, if you subscribe to Airtable and you want Airtable to be highly available, and you want them to be 4 nines or even higher, and they also, I think this is also the SaaS provider's value proposition to you as well. And people building applications with those services, and you don't want the response time to be slow. You want them to be fast. Ideally, like you are using TikTok or Pinterest or Facebook or Instagram, they are like sub-second latency. So you feel that is to be interactive. And then the third thing is that from the SaaS provider's perspective, they need to support large number of users, large number of tenants. And each tenant can have several or hundreds of like thousands of users. So there's definitely a scalability requirements for the SaaS service. And also nowadays, SaaS business models, they usually provide different tiers. For example, they usually have a free tier for user to experience value. Then once people are satisfied with the experience, they usually choose an upgraded tier. And then there are also like an enterprise tier for large customers. And from the SaaS business growth perspective, when the product just launched, it starts with mostly trial users, but over time, it kind of transitioned to mostly like enterprise users. And from this transition, you do want to provide, the SaaS provider do want to provide isolation and the qualities among tenants. And you don't want your free tier users to disrupt the availability or kind of like a performance of the enterprise users. And they also want to have the onboarding of the enterprise users to be easy, so that once you onboard, you don't want to be in the situation that when you onboard a large tenant, then everybody kind of like is not able to use the software. So I think from this perspective, traditionally, the SaaS provider usually ends up with architecture like this. It has an application plane, and it also has a control plane. Or the application plane, I think about as a data plane. It's really the services and the databases that store the user data, whereas the control plane mainly store the metadata for running the SaaS. For example, they can be billing data, access control data, and the tenant and user profile. And also, those can be object mapping between the object you see in the application and the object you see in the databases. And also the business operation perspective, you want to understand the cost, the performance, and the usage pattern of your SaaS platform. Then you can continuously improve your system. So that's the control plane. And you can see the control plane has many microservices, and each microservices will be powered by the databases. And this, as you manage a large number of tenants, the data of the databases can grow. It can be the case that it no longer be able to handled by a single node databases like MySQL or Postgres. And also you want the control plane to be highly available, because if the control plane down, basically users will not be able to access their data. So that's control plane. And for the data plane, or the kind of like the application plane, since your model is from like non-critical customers to critical customers, and you want to provide isolation between different tenants, and the simple solution will be having different database instances for different shards or for different tenants. For example, you may have a cluster or shard of database that hosts all your enterprise tenants. And you may also have a shard or a database that hosts your free tier tenants, and you want them to be together. So in other words, in SaaS world, it's in a very early stage, the SaaS provider has to shard their database because of they need to offer different tiers of services to their customers. And then they need to provide the performance and the isolation guarantees of different services. So shard is much earlier in SaaS compared with internet applications. But however, if I look at the kind of the workload on the databases for SaaS applications, I won't say that sharding actually adds a lot of challenges to the SaaS providers. For example, because the SaaS applications need to support many tenants, and different tenants tend to have different data sets. So from the database perspective, it's really like a random access pattern. And then the challenge is that which means that for a single node database, the data or the workset is hard to be cached in memory, and then the performance can be an issue. Also, SaaS applications need to run complex or ad hoc queries with joins and aggregations to support different views of the data. And this also kind of like add challenges to the database, mainly because the single node database has limited capability to support joins and aggregations. This can be very, very slow if people issue many of those queries. And the third requirement, because of the data integration between different data sources, there can be periodically data import and synchronization workload on the database, and that can also disrupt your query performance. And the fourth is that you need frequent schema change because the user data can change over time very frequently, and the different users has different schemas. And the traditional single node database doesn't support this very well. So the schema change is not online, and then it actually blocks, the DMLs, which are the data modification languages, and that can cause expensive like schema migration, and that is very slow. So based on this, I think this architecture with sharding creates a lot of pain points. And I think here are some of the pain points. Adding new functionality takes a long time because of there's no isolation, and they'll be challenging when onboarding large customers. And moving a tenant to another instance is very painful, and you have to do database migration. And it's hard or even impossible to avoid downtimes. And then one tenant can simply become too big and cannot be supported by any single instance databases, and then you need another solution. So here I want to talk about with TiDB, the sharding can mostly limited, and you can continually grow your business and tenants without any issues and downtime. And with TiDB, you can see that all the microservices can actually be powered by a single database, and all the different tenants can also be powered by the same database. So that is kind of what TiDB brings on the table. So I think the biggest value here is that so TiDB is a scalable database, offers SQL and the secondary indexes at scale. It also supports transactions. So from the usage perspective, TiDB is like MySQL, single node MySQL, but under the hood, TiDB handles scalability, failover, and then resource controls under the hood. So the user don't need to worry about them. So that's why TiDB can support as a single database for many microservices and for different tiers of tenants. So what is TiDB? TiDB is distributed SQL. I think you don't have to do manual sharding, and it is MySQL compatible, and it's offer horizontal scalability out of the box. And it offers the built-in high availability, ACID transactions. It's also open source and cloud agnostic. I should mention that it's not a fork, not a middleware, or not SQL on Hadoop. It is inspired by Google Spanner, and it's kind of crafted from scratch and battle tested over the years, and has been used by many internet companies in the Silicon Valley and other places in the world. So here's what kind of the improvements a leading CRM SaaS provider sees by migrating from their traditional architecture powered by sharding, MySQL sharding, to TiDB. I think their challenge is that they need to provide the end user the capability to look through the customer information in real time. And with MySQL or MySQL sharding, that type of query is very slow because one of their users are customer support representatives. And oftentimes when they answer the customer calls, they need to search for the CRM to understand what's going on with this customer. And this needs real time and it needs fast response. If the query is slow, then it causes a lot of frustrations to the customer support representative as well as the customer. And with MySQL, those type of queries typically take more than 30 seconds or even minutes. But with TiDB, those queries can be down to less sub-seconds or only like a few seconds. So that's greatly improve the user experience when users try to serve their customers. So here's a demo. I cannot show kind of like the, because it is a, I think the demo has some issues, but here is really a video I want to show you. It's displayed again. The idea is like the left-hand side is open source CRM powered by MySQL, and the right-hand side is open source CRM powered TiDB. And most of the time, people will create different views of the data in their CRM to understand what's going on with the business. And with TiDB, you can see that those different views displays almost instantly. With MySQL, actually, you see there's a lags between them. And imagine that you are in the situation of you want your CRM to return what's going on with this customer when you're supporting your customers. I believe that with TiDB, you should be much more confident and much more happy compared with using MySQL sharding. Simply because of like TiDB has the capability to scale and providing kind of secondary indexes for fast queries. I think this is kind of like the end of my talk today. And this is the part one of the talk. In the part two, I'll spend time explaining the internals of TiDB and show you why TiDB can provide those capabilities that making developing SaaS applications to be easier, as well as providing better user experience to the SaaS providers, customers. And that's all.
Great. Thank you, Liquan. Appreciate it. So as Liquan mentioned, we do have another webinar coming up in this series. So we'll be emailing you about that. That will be coming up in the next couple months. And we'll be sending out the recording to this session as well. So let's take a few questions while we have a little bit more time. So the first one is, Liquan, what makes a distributed SQL architecture a good solution for SaaS applications compared to other distributed databases?
Yeah, I think there are a couple of dimensions. First of all, SaaS application is a natural extension to the traditional enterprise applications, which means that their application logic is very complex. So I think that that's one thing. And usually the traditional enterprise applications are built on top of relational database. But traditionally, before distributed SQL, if you want to scale, there's not many options available to you. You either do sharding or use NoSQL. However, sharding or NoSQL eliminates many benefits provided by a relational database. For example, SQL, for example, transactions, for example, the global secondary indexes, those are no longer available to you. And you do have to, the application level, kind of like a developer has to build their own query layer realizing that the database is sharded or this NoSQL. This adds a lot of complexity to the application developer. And with distributed SQL, from the user perspective, they still has SQL, has secondary indexes, and has ACID transactions. So it's just like a kind of like a single node database. And architecture perspective, under the hood, for example, like a distributed SQL is usually a SQL above NoSQL, and the data in a relational or distributed SQL is encoded as key value pairs in the NoSQL storage, and then the distributed SQL has a distributed transaction protocol, making sure that the transaction is still maintained at scale. Yeah, I think those are a few key points in the architecture design of a distributed SQL that make it good for the SaaS applications.
Okay. The next one's really specific to TiDB, and they're wondering why we developed a new Raft engine
Yeah,
for
sure.
our product.
Yeah, sure. So I think there are a couple of dimensions. If you look at TiDB is a multi-raft system, meaning that so think about TiDB as so TiDB tables are large tables, right? It can contain billions of rows, and those tables are represented in storage as a large key value map, right? And then the large key value map is divided into chunks, and each chunk is actually a raft group, and we have multiple replicas for each chunk. So from this perspective, really is there's no one actually done this before. So because Raft can offer high availability, but it cannot offer scalability. In order to offer scalability, you have to chunk your data so that multiple Raft groups can achieve the scalability goal. So that's why we design a multi-Raft system instead of purely using a single Raft system. So, and that's one thing. And I think if you there's another dimension to this, really ties to the details of TiDB's implementation. Really like in the Raft world, there's a log of commands, and that is replicated across replicas, and then apply the log. The command keeping consistent by the Raft protocol. And then once you apply the log, the command, then the state will be the inconsistent. We were using RocksDB to store the log store the Raft log. Now we are using a new engine called the Raft engine to make the store the Raft log more efficient. Yeah, there are two kind of like dimensions to answer this question.
Okay. We have time for just one more question, and so let's say they're asking about migrating to a distributed SQL database. Yeah. So yeah, what does that look like? I mean, adopting this and sort of the initial tasks, and ultimately what's the effort here?
Yeah, sure. I think definitely that's a good question. So definitely TiDB is a good database for your application, but if the migration is very hard, then that can be a challenge. Actually, we do provide tools to migrate from MySQL or sharded MySQL to TiDB, and we call it a data migration tool. The idea is very simple, very straightforward. It's basically a combination of taking initial snapshot of the upstream MySQL database and then load to the TiDB, then sync from Bing log to TiDB, and that's about it. This is basically a solution you can use after the box for you to get started. Yeah.
So speaking of getting started, on the screen we have our options for adopting TiDB. Can you just speak to each of those real quickly?
Yeah, definitely. So So TiDB is open source from day one. You can actually you can search in GitHub. We have the TiDB repo there. It's over 30,000 stars and many forks. And then over time, you can deploy TiDB self-hosted by downloading software, follow our instructions, and it can be deployed in bare metal on the EC2 or on Kubernetes. So by EC2, I mean really the cloud machines, right? And then we also offer fully managed services or fully hosted services. And we have two offerings. One is TiDB dedicated, the other is TiDB serverless. Dedicated is very similar to the self-hosted mode. The difference is that it's running by us, and we will monitor the alerts, monitor the issues for you, and then provide operations for you. It's really a fully managed, and today it's available on AWS and GCP. And then the third one is we have serverless offerings. Serverless offering is a different pricing model. It's basically if a pay-as-you-go model, you can start with zero cost, and then we provided a few data sets for you to play with to understand the benefits of TiDB. And it's very low start cost. You can connect TiDB serverless with your application, and then as your data size or your QPIs goes up, or you can just buy more of the quota. It is kind of priced by the number of read and write units. We call it resource units. It's fully managed, and this auto scaling is pay as you go. Yeah, and I think once you feel that you have some critical workloads with TiDB, then you can use TiDB dedicated or TiDB self-hosted.